Good day. My name is Phil Zamperin, and I work as part of the Quality and Regulatory Affairs Group. Today we're going to be discussing your critical role in quality. What is quality? Quality can be defined in many different ways. Some people define it as having consistency, a consistency of a particular product. It's the same every time I buy it, or it gives me the same output every time I buy it. It's reliable, something that I can count on. It's perceived as being perhaps value for cost, something that may be inexpensive, but relatively works the way I need it to. Something that's long-lasting or durable, something that's tough or strong. Some people compare quality to, for example, two products that are the same, and one seems to be, in their perception, built better. The most important thing that we need to know when we're trying to define quality is that most often, or quite often, it meets my expectation when people try to define it. And the key word there is my. Quality for everybody is going to be different. No two customers are the same, and their expectations are going to be different. So the my, or the subjective part of it, is what we need to delve into and understand. Quality itself has been defined as fundamentally relational. Quality is the ongoing process of building and sustaining relationships by assessing, anticipating, and fulfilling stated and implied needs. Some key words within this statement: the anticipation of requirements. The anticipation is, do we understand not only what the customer has told us, but what we think they're going to need. Assessing: have we properly assessed the customer's request to ensure that we understand their entire need? And then the last two parts there are the stated needs, what the customer is specifically asking us for, and the implied needs, what they don't have to tell us. It's the expectation that they have on our products, even without saying a word. So what does our customer want? We break it down into two specific set of requirements. The first set of requirements are called implied requirements, and the second set are called specified or requested requirements. The implied requirements that our customers traditionally have on us are things that they typically don't have to tell us in a specification. They just somewhat expect it. Things like, when I'm buying a steel drum, I anticipate or I expect that it's not going to leak. I anticipate that it's going to hold my product. I anticipate that it's not going to damage or destroy my product by contaminating it. Will it withstand the transportation mode? Almost an expectation. They're buying a package to protect their product so that it withstands the transportation mode. And does it represent my product? Most times when a customer places their product in our drum, our package becomes their product. Those are the types of requirements that customers really don't define for us. They don't give us implicit specifications. They don't say that it has to do all these things. They're expected. These are somewhat foundational. And typically when we fail in these expectations, it's somewhat a quick loss of trust, because the customer quickly understands that you may not be able to deliver just the basics of what you're supposed to be delivering. Specified requirements are requested. Those are things that typically come with regards to the customer's contract or order. It's like, for example, I want a particular size container, like a 55-gallon drum. I want a certain lining that goes within that container. I would like to be shipped on a particular date, or arrange it in the truck in a particular way. These are all specified as part of a contract or as part of a particular sales order. And they're just as important as implied requirements. The customer is expecting the same level of us servicing their needs as with the implied requirements. But for us to really truly understand quality, we have to understand both of these sets of requirements. Production accountability and why. For us to have accountability on the shop floor, we need to understand the whys. Typically, when we're manufacturing a customer's product and we need to understand those needs, we have to follow a particular plan that's going to actually allow us to execute and deliver those needs. So the development of that plan is key and critical. And does the plan connect to the requirements? Can they be clearly understood? The connection between our plan and the customer's requirements, whether they be implied or specified, is key and critical. And the clarity that surrounds that is even more so. We have to understand these requirements in the same way at our level and at the shop floor. Do we have the right tools and equipment to do our jobs? If we don't have the right tools and equipment, how can we properly assess the customer's product to ensure that we've met the acceptance criteria? Are we providing them with the right resources to do their job? Do they have what they need? Whether it could be a particular measuring equipment, tool, fixture, or it even could be light over their inspection area to ensure that they can actually visually see what they're looking at, what they're supposed to be assessing. Do we engage and involve the right team members in the process? Quite often we feel that as quality leaders, a lot lies on our shoulders to resolve quality issues. But in reality, it lies on everybody's shoulders. We all have to take part in the process. And involving the right people and the key people to allow us to walk through that is key and critical. Are our critical colleagues empowered to make the difference? Critical colleagues exist within all levels of the organization, but none more important than on the shop floor. Do the people on the shop floor understand that they have the power to, for example, determine if something is good or bad in the eyes of the customer? Can they raise their hand and stop the process? We have to ensure that our employees are empowered to make the right business decisions if they are in fact measuring for acceptance. Do we listen to our employees? Are we taking action? Are we taking action when necessary, and are we taking the appropriate action? The quality system is not one person or one department. Quality relies on everybody's contribution. When we look back at the different level of requirements, it's clear now that all employees must be knowledgeable and mindful of both types of requirements, not just the quality leader or the plant leadership. It must be everybody within the organization if we're truly going to have success in meeting these requirements. How do we express implied and specified requirements, and how do we ensure that they're understood? Some of the typical methods that we have deployed to satisfy these implied requirements are control plans. A control plan is a document that allows us to analyze the entire process from beginning to end and define the key and critical areas at which we must ensure certain aspects or characteristics are in line with customers' requirements or with the manufacturing requirements to ensure that the outcomes satisfy their needs and the actual implied requirements for that product. Some of these control plans aren't typically laid out on the shop floor. They're somewhat defined or redefined in what we call the operational standard work documents. There's many names for these documents, but in most cases they're called OSWs or operational standard work. Some plants call them work instructions or standard operating procedures. But they describe or they articulate what's in these control plans and how we're to execute the job at that particular work center or machine. Another common tool that we utilize is a visual quality system, giving us 4 key pieces of information: the operational standard work, it gives us the specifications, the autonomous maintenance, and the machine settings. All these are laid out on the shop floor for the operator and for any individual who might be part of the process, so that we all have a level and aligned understanding of what the manufacturing standards are and whether we're complying to them or not. Lastly, our quality checks, inspections, and process controls. Those are all the intricate, for example, all the information related to the inspections we're doing and the quality records at which we're actually recording the information on. Some of that is in manual format. Some of it may actually be in electronic format, such as statistical process control software or quality characteristics with inside LN. The process controls are another key and critical area that we have to ensure that we meet. Sometimes you're not measuring actually the product or the component, you're measuring the process. And the process, through the control of the process, we actually ensure that we're meeting the manufacturing standards when some of these standards cannot be measured. An example of a process control could be the temperature within an oven or the pressure at which we're applying in a certain hydraulic pump or process. Expressing specified requirements. How do we typically define the specified requirements? Remember, specified requirements are the things that are somewhat unknown to us, even before we sign a contract with the customer. They're not what the product should do. It's more along the lines of this is what the customer wants for a particular order. The common tools we use are master production schedules, daily production run sheets, work or shop order forms, shipment schedules, loading documentation, and customer requested order documents. Again, the details within these help frame up what the customer actually wants for their particular order. And they may be different order from order. So I would say that your implied requirements are more commonly static, unless you have new products or new materials, which may drive a management of change process to change your standards. Whereas the specified requirements are very dynamic and may change from order to order. Does everybody know the game plan? So once these requirements or customer needs are defined and well known, does everybody know what position they're playing with inside this plan? It's kind of like a game, a soccer game or a football game. Are they adequately defined on our standard work in BQS? Are the operators trained and certified so that they understand these actual requirements and how to meet those? Do we have proper shop floor engagement? Are we actually verifying what's taking place on the shop floor? And do they understand where to go to when they need resources? And then lastly, most importantly, do they feel empowered to take action when necessary? It's upon us as leaders to ensure that everybody within that process understands their key and critical role, and what they do matters. It matters regardless of whether they're receiving product, conducting a component operation, whether they're making a steel sheet or a manufactured part. Whatever they're doing will ultimately affect or impact whether or not we meet our customers' needs. So it's absolutely critical that everybody understands how they impact this process. So just to reflect, do we understand not only ourselves, but the entire organization that's actually manufacturing the product? It's very difficult for somebody to contribute to a quality management system or product quality if they don't even understand what the needs are of the customer. It's upon us as quality leaders, we must instill upon the organization that we all share a responsibility for the quality of our products. Some of the key and critical shop floor elements that I'm going to cover in the next sections are tools and equipment, the equipment that we're using to actually determine whether a process is in control or whether we're meeting acceptance criteria. The production or quality records that we're maintaining throughout production. And then lastly, what do we do when things go wrong, when we make something that's non-conforming or doesn't meet the customer's requirements? How do we engage and how do we handle that? In this section, we'll cover tools and calibration. Tools and calibration are a key and critical role on the shop floor, and they help us establish shop floor accountability. If we aren't using the proper tools, if the tools we're using aren't calibrated, then it's hard for us to ensure that we're actually meeting or we can actually meet the requirements of the customer as specified either in our plan, the implied needs, or within the customer's specified requirements, like the shop floor orders that we send out to the floor. So one of the things we have to be mindful of, and we have to ensure that that's correct on the shop floor, is that as the quality leader, do the people performing the inspection and measuring of the process have the right tools to do their job? These include inspection equipment, fixtures that might be used, and even the process controls, such as pressure gauges or temperature gauges. The right tool that's capable of meeting and determining product acceptance standards, traditionally there are several ways that we can do this. One example is the rule of 10. If we're measuring down to a particular degree of accuracy, we have to ensure that our gauge is not only accurate to measure it, but is accurate enough to the point where it can measure a variance or a variance in the measurement. One of the common tools there is the rule of 10. For example, if we have a specific requirement where our total tolerance is 1 millimeter, we would want a gauge that can measure down to 1/10 of that actual total tolerance. That gives us a high degree of accuracy that we can actually determine how close we're actually within tolerance or without a tolerance. Equipment must also be repeatable and reproducible. One of the common tools that we can use to determine that is a gauge R&R study, which actually allows you to determine the variability of the measurement process itself and the degree at which we as people measuring it and interacting with the measuring equipment, how much of that actual tolerance is being chewed up with just the actual capability of us being able to repeat and reproduce the measurement. Go no go fixtures and templates are common in our workplace. We use these to quickly assess product acceptance. The only thing that I would say about a go no go that is a concern is that, you know, quite often, although they tell you if you're good or bad, they don't tell you how close you are. So the ability for us to monitor a process becomes limited when we're using these types of gauges. But all these gauges are in use. All these types of tools are in use. We have to ensure that we're using the right tool for the right job. Calibration is key and critical for our measurement tools. Without calibration, we wouldn't have clarity as to whether our gauges actually are in compliance with national standards. Is what the gauge telling us actually correct? And that's essentially what calibration is. It's the validation or verification that what your gauge is saying is actually correct. It helps us determine if the gauge is in working order, whether it meets national standards. And lastly, it allows for traceability. If we didn't have traceability back to our tooling and its calibration status, it could mean that a lot of our products that were manufactured and measured with this gauge could be compromised. This section will cover records of inspection. The importance of production records. The typical information that we collect during production are our process and performance data and inspection data related to the production. The results which we're achieving during the production inspection process or process control, who performed the inspection and when the inspection was performed. And then lastly, the results of the measurement and whether we passed or failed. These records are collected in many different ways. We have manual records, such as you see here on the slide, or we collect them electronically, such as LNQC characteristics, or with inside HMI devices or tools that we're using like process control or statistical process control software. A lot of this information or production data is collected and connected to the production order, work order, and actual materials that we're using during production. The reason why it's so important that we collect this data and we collect it accurately is we use it for a lot of different reasons. One of the common and key reasons is that our customers depend upon it. They depend upon us knowing the status, not only when we're producing, but the status of the production even after it goes out into the marketplace. These records are important for us because we can actually trace backwards to the raw materials that we've used during production, and we can trace forward to where those raw materials were used and out in the field in case we have to recall products if necessary. The methods for how we accepted it and whether we made adjustments or not are also detailed in these production records. It indicates how the process was running, how the machines were behaving, whether we were having issues during production, something that might be a leading indicator when we have issues in the field, especially issues that might be insidious that we don't necessarily check or that we don't necessarily understand at the time of production. Could be, for example, a contaminant or a lining failure or a actual leaker that's maybe a weeper leaker. This information is critical for us to sort of trace back and determine whether we actually met and stayed true to the manufacturing standards and the customer's specified requirements. Trends analysis. Trends analysis is data that we collect over time. It can give us an indication of whether we have wear and tooling, whether the process maintained its control, and it can also lead to us allowing us the ability to bring that data into improvement projects such as A3 projects. Production records tell us the story of how we ran that order or for a particular production period. Controlling non-conforming outputs. So what happens when we don't meet the plan, or when our plan fails and we don't meet our customers' needs, whether implied or whether specified? There are certain activities that we need to take place, and we need to ensure that everybody has an understanding of what to do when this occurs on the shop floor. We've seen it commonly out there in the field. We've heard lots of news stories when quality isn't met. Some of the more serious and more recent news stories that we've seen lately is, the door plug falling out of a plane, out of a Boeing 737 MAX 9, all related to quality at a particular facility. Somebody failed to actually put the bolts in the door, and then somebody failed to do the inspection. And nobody verified that the records were actually done to ensure that the process was fully complete. You see here the real life consequences of us not following the plan. Obviously, anybody as a customer didn't need to tell Boeing that, hey, I want the door to stay into the door plug to stay into the plane, and it's absolutely critical for me. However, so those would be somewhat implied needs. Boeing needed to address this as part of their control processes. What if we failed to act? The Challenger explosion, the Space Shuttle Challenger explosion, was the result of failure to take action. The problem with regards to the O-ring seal that was in the solid rocket booster was known from as early on as the first shuttle mission. It was the normalization of this deviation where everybody sort of implied that past success does not equal future success. And they translated it to past success must equal future success. There was a particular issue that was known with this O-ring in this solid rocket fuel booster that eventually would fail one day. Nobody took action. The result of lost life, a loss of a mission. When we fail to act, a lot of our products contain hazardous materials or materials that are, as our purpose states, made for life's essentials, such as pharmaceuticals or food. When our products fail in the field, it impacts these types of products. If we have, for example, a leaker, we could see a situation like this where a hazmat team is deployed to actually clean up the mess wherever it is. Commonly, the materials that go in our package are highly hazardous, and individuals, have to be trained just to handle these, and to handle them in an open environment puts the safety of not only the environment but the people surrounding it at risk. When we fail to act, or when we fail to hold up to our responsibility with regards to food and pharmaceutical type products, we could be contaminating products, putting people who are consuming these products at risk. So there's a number of issues and real life scenarios that take place on a daily basis when we have complaints from our customers. And these scenarios all are because we failed to act or we failed to follow our plan. So what should we do when there is a issue in us meeting the customer's needs? If our customer's needs are well defined and we all understand them, and we see that there are issues and we have not met a particular need, whether it's implied or whether it's a specified requirement, we need to stop. Stopping prevents waste. With the empowerment of the employees, it allows us to stop at any point. So rather than wait until we reject the product at the end of the production line, we can actually empower the employees so that they can stop the process early on when they first detect the issue. Most issues, when found in final inspection, are the result of upstream processes. So it creates opportunities for us to learn this as well. Once we identify an issue, it's an opportunity for us to address this issue and correct either the control program or the processes that are creating this defective situation. After we've stopped, we need to notify people. Make sure that the right people are engaged in this. So we need to listen and react to the issue. So first and foremost, if we're not listening to the employees, we're never going to hear or address their needs. We have to establish strong communication channels. So it's almost automatic. When there's an issue on the floor and we stop, that communication channel should be well defined and be to the appropriate people who can resolve the issue. And we need to start the healing. How can we fix it? How can we resolve the issue? We need to identify any material that might exist not only within our particular environment, such as within the facility, But we also need to use those tools that we had from our production records to identify any materials that might be existing out in the field. So this identification, when we do identify products, it must be clear. It must be so that anybody that walks into your facility can quickly identify what's good and what's bad. So that clear identification is very powerful. Knowledge is power. Us knowing good from bad is powerful. And again, it must be clear to everybody that walks through your facility what's good and what's bad. And everybody must be aligned to these standards. Segregation. If there are defective materials in the process, they need to be properly segregated and moved away from good materials. So the segregation of the materials and the confinement of this material is key and critical, as we don't want these materials going back into the process and being used as if they were good. Traditionally, there is a control a non-conforming process. One, it does exist, and which was covered in the previous training session, called control a non-conforming product. And there is a QS application that is specifically or tailor-made just for this specific element. That system allows us to properly identify the materials, catalog and log them, and apply disposition. The disposition is, how are we going to use this material? Are we going to scrap it? Can it be reworked and saved? Are we going to use it as is? So all of this process is controlled within that QS application. Typically, when things are used as is, it needs to go through a series of approvals. If somebody's taking the accountability for actually saying this is good, it does meet the customer's requirements, or it does not impact our implied needs, traditionally somebody's approving that. And then accountability. The documentation of this whole entire workflow from stopping to notifying to identifying to dispositioning the product must be accountable. It must be recognized and seen and transparent within our processes. And lastly, take action. When there's issues that occur in the facility, listen to the employees and finally take action. What are we going to do to resolve the issue to prevent it from reoccurring? Taking action involves a couple key areas or key steps. The first step is to develop a team. Again, quality just doesn't lie on the shoulders of the quality leader or the quality department. It involves everybody who touches the manufacturing process. It could be maintenance individuals, leadership, the operators themselves. All these individuals are key and critical to resolving or taking action. And we must seek input from all of those individuals. It involves investigation. We want to ensure that we have all the information we need to properly assess and determine a root cause. It involves the analysis using problem-solving tools, such as Ishikawa diagrams or fishbone diagrams, and then 5 whys. Using those tools that are provided to us from the continuous improvement team that allow us to actually delve down to the root cause of the issue. And then ultimately, action involves action. What are we going to do to address the root cause? The more we evolve, or the more evolutions that we go through this process, the more robust our systems become. This next section, we're going to talk about the mindset. Our behaviors as quality leaders drive a lot of what goes on on the shop floor. The way we behave and the way we approach quality means a lot to how others follow us. Some of the key behaviors or key mindsets that I'd like to sort of go back if somebody had asked me, what were my 5 top behaviors for a quality leader? I would say the first one is caring. Do we care enough about our team members, shop floor employees, supervisors? Do we care enough about them to develop them? Do they understand their job? Do they understand the customer's needs? Do they understand both the implied and the specified needs? If we're not taking time to develop the person so that they can contribute to the quality management system, then we're really not caring about the individual. Empathy. Empathy is key because we need to put ourselves in the shoes of not only our shop floor colleagues, however, and the supervision and the people that are part of the quality management system, but also our customers and what they see. So having empathy, for our customers and for everybody that's involved in the quality management system is key to understanding and defining these requirements or needs. Being open-minded. There's more than one solution. There's more than one way that we can meet the goal or the objective of satisfying the customer's needs. Having an open mind and listening to people that we're trying to actively engage with, whether they be the individuals as part of the corrective action process or people who are measuring things on the shop floor and we're providing resources for, we need to have that open mind and listen to the individuals. Courage. Courage is critical. Without courage, can we really stand up and say that there's a problem? Can we take action when action is needed? Courage is foundational. Not only do we need it, but we need to ensure that people on the shop floor have the same courage. It's difficult for somebody, especially newer colleagues, to actually join the organization and just imagine them out on the shop floor, not knowing much about the products, not knowing much about the customers, and then having that courage to actually stand up and say, I think there's a problem here. And that's what we really need to build within our organizations, is not only courage for ourselves, but courage for anybody that's part of that process of determining whether we've met the customer's requirements or not. And then lastly, be action biased. Take action. When action's needed, drive this activity. Don't walk past the problem. Ensure that we quickly act on things and quickly resolve issues. Just as a review, in order for us to be the best performing customer service company in the world, we must understand our customers' needs and satisfy them 100% of the time. Some of the things we talked about was defining quality and how Greif defines quality for the products we manufacture, both the implied and both the specified requirements. We talked a lot about the production accountability and what we need, those key and critical elements on the shop floor that we need to address, and so that not only us as quality leaders are accountable for it, but also the entire organization that manufactures the product. And then lastly, we touched upon the mindset, the key components or the top 5 mindsets that I believe are common for quality leaders. Again, we must instill upon the organization that we all share the responsibility for the quality of our products. So just a high-level review to summarize the training event. First is ensuring we have deep understanding of the requirements. Second is to connect these and promote awareness of these requirements on the shop floor. Ensuring measurement and record validity. Empowering our employees to take action when necessary. This concludes the second edition of our quality trainings calendar. I hope you enjoyed it. Certainly, if there are any questions, you can reach out to anybody within my department. I want to thank you for your participation and for your ongoing commitment to quality. Thank you.